This is our third video, and so on this one, you may notice it's not in the format that we're used to seeing. I see that I have x squared. I'm going to complete the square and then figure out what's going on with this one. So on this, because my goal, I see that the x is squared, my goal would be to equal y, to get to y is equal to 1 over 4p times x minus h squared plus k. So I'm going to keep the y on one side and then put everybody else on the other. It's not the only way to do this, but here we go. At this point, notice I'm going to start here for just a second. And then, so let's rewrite this. So negative 8y is equal to x squared minus 2x. This is what I need to complete the square on. And I have plus 9. But if I add a box, I can either add a box to the other side, or I can subtract a box from the same side. So in essence, I am adding nothing. And I'm going to do it this way because then this gets me closer to that form. It's not the only way to do it. If you don't like this way, you have other options. But so then I have negative 8y is equal to x minus 1. 1 squared gives me a 1 in the box. And this becomes plus 8. And so now I'm almost to that form that I want, but I need to divide by negative 8. So I have that y is equal to negative 1/8 times x minus 1 squared plus, well, 8 divided by negative 8, is minus 1. Okay, so now my hk, my vertex, is 1, negative 1. My p-value is going to be negative 2. This is going to open down. What else did they ask for? The focus. Okay, so basically, I'm here at 1, negative 1. And my p-value is negative 2, so here's the vertex. No, this is the vertex. This is the focus. So sorry. My LR is 8, because it's the absolute value of the denominator here. And my LR is 8, so then I'm going to come 1, 2, 3, 4, 1, 2, 3, 4. I don't know, something like this. What else? So then the axis of symmetry is x is equal to 1. The directrix is going to be 2 units, so the directrix is here at y equals positive 1. So there we go. The next one, we have a little bit more. This next one gets a little bit more involved, and it's kind of cool, but hang with me. Actually, let me do the word problems, and I'm going to do this one in its own video. So this one, they're saying there's 7 radio telescopes. Okay, for each parabolic. So what they've done is they've taken a parabola and they've rotated it and made a paraboloid, or whatever. It's 3-dimensional, and the diameter is 25 meters, and the distance between the focus and the vertex is that much times the diameter. Write an equation. Okay, so if we've got this telescope dish. They're saying that the diameter all the way across is 25. And the distance between the focus is, so here's the vertex. And somewhere their focus exists somewhere. So I don't know if it's here, or it could be inside or outside. But let's just put it here, and we'll assume that we're not drawn to scale. So this is 0.36 times 25. I don't know. 0.36 times 25. Okay, so that has this value right here is 9. So they're saying what they want to know is they want to know how deep is this right here. So we have that our p-value is equal to 9. Let's make our life easy and say that the vertex hk is 0, 0, because might as well make that 0, 0. So then this is opening up. We have that y is equal to 1 over, well, 4 times 9 is 36, x squared. So then they're saying, well, how deep is the dish? How much if I travel 12.5 units in the x direction, or negative 12.5, what is my y value going to be? Okay, so when x is equal to, well, 25 over 2, because I want to go half of that, or 12.5, what do I get? So I'm going to grab a calculator. And so this is 1 over 36 times 12.5 squared. And I find that it's something that it's about, oh, what's its fraction? Oh, that's lovely. Okay, it's about x is, I lied. y is about 4.34 feet. So really and truly, I did not draw that to scale. This would be, the focus is going to be up here pretty high, and this is going to be 25 feet across, and this depth right here is at 4.3. So then this whole thing, 9, would be somewhere like that. Okay, let's do this last word problem, and I'll save the last video for the slope of the tangent line sort of thing. The cables of a suspension bridge are in the shape of a parabola. A suspension bridge typically has kind of a tower here and a tower there, and then the wire comes down something like that, like a parabola. Pretend I can draw. The towers supporting the cable are 600 feet apart, and they're 80 feet high. So they're saying that it touches here in the middle, and we want to know what's the height of the cable at a point 100 feet away from the tower. So we want to be 100 feet this way. But notice 100 feet this way and 100 feet from this one, this value here and this value there are going to end up being the same. Okay, so let's let our vertex be 0, 0. And now what I want is, this is the point, well, I've gone 300 and then up 80. This is the point 380. So y is equal to, this is where I would use ax squared instead of 1 over, because they don't, in this particular problem, we don't care about the focus or the directrix. We just need to figure out the height right here. So when I plug in my x and my y value was 80 times, this is 300 squared. Okay, so now I have that my, this becomes 80 over 300 squared. My a value is 1 over 1125. So now I've got the equation y is equal to that. But I want to see what happens, what's my height when I'm 100 feet from here, or that would be 200. So this whole distance, do you see what we're looking at here? This whole distance is 300. I want to be 100 away, so I want x to equal, when x is equal to 200, what happens? So I have 1 over 1125 times, just kidding, times 200, squared. And that's when the y equals this, which is lovely, but you tell the guy at the lumber yard what you want, and he doesn't know what you're talking about. So this is about 35.556 feet high. Okay, so there's some problems to practice, but I do want to go back. In the last video, I'm going to talk about this one.